Welcome to Summarize Science. We all use AI language models, but we also know they have a major flaw. They sometimes hallucinate or just make things up with complete confidence. To solve this, scientists are developing methods to estimate an AI's uncertainty, essentially trying to get it to raise a digital hand when it doesn't know the answer. But this paper asks a critical question. How do we know if these uncertainty detectors actually work? The current evaluation system is broken. It's like having several different teachers grade the same test, but their final scores for the same student are wildly different from one another. This chart shows just how much these different automated graders disagree, making it hard to find the truth. This disagreement leads to a huge problem the paper calls correctness hacking. As you can see in this table, by cherry-picking the right grader, a method's performance can be artificially inflated, sometimes by a massive amount. This makes it almost impossible to know which uncertainty detection method is truly the most effective. So, how do we fix this? The researchers propose a few clever solutions, starting with the wisdom of the crowd. Instead of relying on one potentially biased AI judge, they suggest using a whole panel of them and averaging their scores. As this graph shows, using just 4 judges can cut the evaluation error in half. Another brilliant idea is to test the AI on tasks with clear, objective answers. Instead of ambiguous questions, they use things like code generation, where the submitted code either works or it doesn't. There's no room for a grader's opinion. Finally, to bring it all together, they propose a grand tournament for all the uncertainty methods. Using the ELO rating system, famously used in chess, they make the methods compete against each other across dozens of different tests. This creates a single, objective leaderboard, seen here, that clearly shows which methods are the champions. It's a much more honest way to see what really works. So let's recap the key points. The way we currently test an AI's uncertainty is flawed and can be easily manipulated. The researcher's solution is to use a diverse panel of AI judges, test on tasks with clear-cut answers, and use a tournament-style ranking for an objective score. What this means for the future is that we're getting closer to building AI we can actually trust. By reliably knowing when an AI is about to give false information, we can build safer and more dependable systems for everyone. This research represents a huge step forward for AI safety.